All right, this is numbers 3 and 4. So in the benchmark 4 test review. Number 3, here are the directions. A particle moves along the x-axis so that at any time t, its position is given by x of t equals 1/2 sine of t plus cosine of 2t. What is the acceleration of the particle at t equal pi halves? So here's our x-axis. Here's our y-axis going up and down. We're not going to actually draw it, but it would be right there at x equals 0. And this equation will give us the position of our particle that's moving back and forth on that line at any time t. So t is a time. And we want to know the acceleration of that particle at t equal pi halves. So this will give us the position. If we do the derivative of this equation, x prime of t, that will give us the velocity of the particle. So let's do that. Got a constant here, multiplied times a trig function. Let's copy down the constant. The derivative of sine is cosine of t. We're doing the derivative with respect to t. So derivative of t would just be 1. Derivative of cosine would be negative sine, so I'm just going to change that to minus sine. I'm going to use the chain rule here because I have an outside function and an inside function. So the derivative of cosine is negative sine. Chain rule says you copy down the inside function of 2t, then do the derivative with respect to t, which would just be 2. Now, what might be good to put that 2 in front of the trig function. You don't have to do that, but I think that makes more sense to a lot of people if you do that. So x prime of t, which is our velocity equation, is 1/2 cosine of t minus 2 times the sine of 2t. Next, we'll do the derivative again. The second derivative, or the derivative of the velocity, will give us the acceleration. So this next equation gives us our acceleration, x double prime of t. Again, you copy down the 1/2. Derivative of cosine is negative sine. You could put that negative up front here. Negative sine of t times the derivative of t, which would just be 1, minus 2. The derivative of sine is cosine. Then you copy down the 2t. This is the chain rule at work again here. Outside function, inside function. So the derivative of sine is cosine. You copy down the 2t. Then you multiply by the derivative of 2t, which is 2 again. I'm going to put that 2 right out front, right there. So actually 2 times 2, that could be called 4. Now we want the acceleration at pi halves seconds. So we're going to do x double prime of pi halves. We're going to take negative 1/2 times the sine of pi halves minus 2 times 2 would be 4 times the cosine of 2 times pi halves, which 2 times pi halves would just be pi because those 2's would cancel. Let's evaluate that now. So we're doing the acceleration at t equal pi halves. And when you think about unit circle here, pi halves on the unit circle is at the top of the unit circle right there. That's the point 0 to the right, up 1. The x-coordinate is your cosine. The y-coordinate is your sine. So right here, negative 1/2 times the sine of pi halves. So negative 1/2 times 1 minus 4 times the cosine of pi. Pi is over here. Cosine is your distance left or right on the unit circle. So the cosine would be negative 1. So this comes out to negative 1/2. Minus 4 times minus 1 would be plus 4. So that comes out to 3.5. Which, or I guess actually it's a multiple choice question on your review packet. It would be choice E, 7/2. So you should circle E on your review packet. That's the acceleration of the particle on the x-axis at time t equal pi halves. Next one, number 4. Y equals the natural log of 3x plus 5. Then the second derivative equals blank. So here we're going to have to do the derivative and then do the derivative again. So you can see it's similar to number 3, and then you have to do a second derivative. So let's just start here. We can call y either y prime or dy over dx. I'm just going to call it y prime in this case. The integral of natural log of 3x plus 5. You might remember to find, or excuse me, not the integral, the derivative. The way you find the derivative is you put 1 over u, 1 over your expression. Then you multiply by the derivative of that expression, which would be 3. So Finding derivatives of natural logs are not that hard. You just put 1 over your expression times the derivative of your expression. So y prime, let's simplify, 3 times 1 would be 3 over 3x plus 5. The second derivative then would be the derivative of this. A couple different ways you could do this. You could move this to the top and call this 3x plus 5 to the negative 1, and then use the chain rule. But what I think I'm going to do is use the quotient rule, because I have 3 divided by 3x plus 5. So I'm going to go low d high minus high d low over low squared. So low would be 3x plus 5. D high, the derivative of 3 would be 0, minus high, which is 3. D low, which would be the derivative of the bottom, would be 3 over low squared. 3x plus 5 squared. So that comes out to 0 minus 9 over 3x plus 5 squared. And that is letter D on the multiple choice question on your test review packet for number 4. Probably the one thing you want to make sure you don't forget to do is to hook on that derivative right here of 3. That's the one thing that people might forget to do. It could cause you to get a wrong answer.